morning. Hot diggity donut. All right. So example 2, it says if the same runner from track 1 or example 1 runs an ultra marathon. There's people that do this ultra marathon, 150 plus miles around the same track. Through how many degrees did he run? So whenever I'm asking you for an angle, like I am here, since there's 2 different versions of the angle, right? Radians and degrees, I'll tell you, right? I'll tell you to give it to me in degrees or radians. This one says to give it to me in what? Degrees. All right. So we're going to use the same formula, S equals R theta, which you have to have memorized. And you can do one of 2 things. You can either solve for theta before you plug in, which is back to the definition of a radian, or you can plug in and then solve. It doesn't really matter. If we're only using it once, I think it's easier to plug in and then solve. But if you wanted to do multiple calculations, it's better to solve for it, because then you could just do plug and chug. But a lot of people have an easier time manipulating numbers than they do letters. So let's go ahead and plug in. Let's see what we got here. The same runner from example 1, ultra marathon of 150 miles. So what's that going to be in my formula? Yeah. Is that going to be SR or theta, 150 miles? It's going to be S, right? Because he's going around the track. Now, he's probably going around more than once, right? But it's still called the arc length. So we'll plug in. We get 150 for S equals. The track hasn't changed. It's 5. Now, here's where you want to be careful. Are these units the same? 150 miles and 5 miles. Yeah. So again, when you're not sure, it's best to include units. All right. And then I don't know what theta is. So now I can solve for theta by dividing both sides by 5. So theta equals 150 miles divided by 5 miles. And then real quickly, what happens to the units? They divide out. And so we get a unit. Right. And now does this simplify, Brady? It goes in 30. Now I'm going to put rads behind it because it's just fun to say the word rad or to think the word rad, because it's short for radical, right? But in this case, radical doesn't mean square root. It means like the antonym of jejune, right? Yeah. All right. So 30 radians. So that could be our answer, but it asks for us in degrees, right? So now, yeah. And if this were a multiple choice test, I would probably have 30 as an answer choice, right? Oh yeah, for the people that don't read, R-E-E-D, read. So I'm going to come over here now and I'm going to convert 30 rads. I'm going to put it over 1 and I'm going to convert it. Now, again, radians aren't units, but having them there as a description gives you something that you can eventually. So rads in the top need to divide out. I'll put rads in the bottom. I want degrees to appear, so I'll put them in the numerator. And now what numbers go where?
180 degrees on the top and high rads on the bottom.
Awesome. There's your conversion factor, right? And now what happens? The rads divide out, and it's time to go to the calculator. So I'll do that. I'll pull this up over here, and we'll load the ROM. Read all those agreements, and then say, yes, I agree. Absolutely. Wholeheartedly. And we get it to work. Yeah, there it goes. It works. Works. Oh, yep, there it goes. Okay. Now we have 2 options here, right? We got pi, which is an irrational number. Do we want to leave pi visible in the answer, or do we want to go ahead and multiply it in? You can leave it visible. I would always recommend, when in doubt, leave it visible. So let's see what that would be. It's in the denominator. So if I left it visible, I would just multiply 30 times 180, right? Which I could probably do without a calculator. That's 5400 divided by pi. And what would the units be? Degrees, okay? So getting a simplified exact answer is never a bad idea, ever. Because if you needed it for a subsequent calculation, you have it right there, right? No rounding error. But in this case, because it's not an angle in radians, which is when we like to see pi visible in the numerator, let's go ahead now and multiply it out, okay? So that number divided by pi, and you always use the pi button, right? Second caret, and that gives us 1718.87. How many decimals? Okay, so that's 873, and then degrees. Now, the bottom answer is not as accurate as the one right above it, but at least we appreciate that number a little bit more, right? We know what the relative size is. So really, the only time I want to leave pi visible as a final answer is if it's an angle in radians. Otherwise, having pi visible is a good idea because it's portable and it's exact, but we always want to accompany it with the decimal answer. Okay.
You can make it more accurate by DMSing the bottom one.
Oh, yeah, let's see. If I let the calculator have all the decimals stored up above, what happens if I go second answer? That's second negative, right? Second negative recalls it from the previous line, and then convert it, right? That would be second apps, number 4. And this is converting it with all the decimals. Okay, I don't know if that's more accurate because it's degrees, 52 minutes, 24.187. I doubt that 187 is the terminating decimal. There's more decimals behind there, I'm pretty sure, but there's no room on the screen to write it. So, but yeah, there might be, yeah, because we multiplied by pi or divided by pi, pi is always going to be that ultimate rational number killer. He's a rational number slayer, right? He's going to make the numbers irrational. Okay. But yeah, that's just another version of the answer. Thank you for reminding us, Brady. All right. Comments, questions? You got it? Same formula. We use it a different way. Answer the question. Yeah. Can you explain how you got it?
I got 150 miles.
Uh-huh.
I multiplied it by the conversion factor of 180 over pi rads.
Oh, you did that first.
Yeah.
Okay, so you did 150 miles. I'm just going to use what you told me, and you multiplied it by 180 degrees over pi rads. You did that? Okay.
And then
And you got a number. I'm going to call this X. Okay. Now look what the units on X is. It's your units right now are miles degrees. Okay, divided by rads. So sometimes you could do calculations in a different order and it comes out with the same answer. But this I don't think is real intuitive to anybody, right? Coming up with degrees or units of miles degrees. We call that an aggregate unit. Okay, kind of like kilowatt hours. That's an aggregate unit. And then you divide by hours and you get kilowatts used. So if you do it like this, what did you do after that?
well, I divided out the pi too. So I thought
Uh-huh. So at some point you took X and divided it by 5, right?
Yeah.
Yeah, so then you took X and you divided it by 5 miles, or yeah, 5 miles. So if you do that, look what happens to the units. Your miles divide out and you're left with degree divided by rads, which gives you what? Degrees. So were you just shuffling numbers around, kind of hoping to get the right answer, or was there a legitimate reason why you did it that way first?
I was just trying to work backwards from what we did in the first problem.
Oh, okay. Okay. Yeah. Well, the bottom line is it works out. Okay. And if you get the right answer and you know what you're doing, it could be a different route to the same answer, right? If you wanted to get from here to your next class, there's several routes you could take and still get there, right? So I wouldn't necessarily count that wrong, but I don't think it's quite as intuitive. It's not the straight line path. You kind of took a scenic route. So if you understand the route we took and why we took it, I would recommend maybe doing that in the future because it is more efficient and it does make a little bit more logical sense, at least to most people, right? Brains are wired differently. So what makes sense to me might make dollars to you, right? Yeah. Okay. Speaking of cents and dollars, there's a donation bucket on top of the water machine. Okay. All right. Thank you for bringing that up. I like that. I like exploring different avenues. Units are always good though to include in your calculations because if you do it differently, and I did say do, your units, when they come out to be what you want, tell you that your calculations are correct. Dimensional analysis, stoichiometry, right? Same thing. Excellent. All right. Hey, once we take a slice of a circle, we can determine its area. Boy, that's fun. Let's take a slice of a circle, like pizza, right? Anyone have pizza yesterday during the bowl that was super? You did? Yeah. You take a slice of pizza. We call that a sector, okay? A sector. Now, pizza is three-dimensional. We're going to look at it from like an aerial view. It's called a sector of a circle. So let's go ahead and draw a circle. I'll use red for like pizza. Well, the crust actually isn't red, right? The crust is kind of like a toasty brown. We got Double Dave's. I like the Double Dave's pizza here in town. Everyone has their own preference of pizza, but I like Double Dave's. Once I had Double Dave's, I'm like, wow, Double Dave's. It's just so far away. It's like it's at Creekside, which is practically San Marcos. All right, so there's the center of a circle. If we look down on the pizza, we could take a slice. Whoa, didn't really connect there. There, and we'll take a moderate slice. Yeah. So this right here is called a what? It's called a slice of pizza, but technically it's called a sector. Yeah, this is a sector of a circle. And what we want to do is find the area. Okay, so here's how we're going to do it. First of all, we're going to define how big or how small our slice of pizza is by the central angle. Okay, theta is the central angle. It's at the center of the circle, right? And of course, we also will know, let's see, the radius of the circle. So we'll call that R and we'll call that R. And what else do we have labeled now? Well, if you were to walk along the crust of your sector, what would we call that? Well, that's not the perimeter of the slice. That's just the perimeter of the crust. The perimeter of the slice would be R plus, what letter do we use for that? S, right? It's the arc length. S for arc length, right? Not S for slice. Oh, it's so confusing, sir. Stadia, stay with me. Okay, good. So those are the variables that we know so far. Yes. Okay, so what we want to do is we want to figure out a formula for the area of that sector. You're tasked with, okay, find a formula that'll give you the area of the sector. And you're like, okay. And then you start. Do your math homework. How would we start? We have to create something, right? We have to derive a formula for the area of that. I don't know if you know it from geometry. Maybe you still have it memorized. Let's say we're on an island and we forgot to bring our sheet of formulas. We just have to use what we know. We need to find the area of that slice, of that sector. Well, what do we know? Let's come over here. What do we know? We know the area of a circle, don't we? You should know that. 2 pi r is the circumference. That's a linear quantity. That's how you can remember that. 2 pi r. R would be measured in feet, right? So it's r feet. Feet measures distance, that's circumference. Area is a squared quantity, right? So it's pi r squared. There you go. R squared would be feet squared or square feet. That's area. So we know that the area of a sector is going to be a fraction of the area of the whole circle, right? It's going to be part of it, not the whole thing. Not the whole thing. So can we use a ratio to help us develop a formula? Will it be proportional?
So if it was like a sector is 1/6 of the entire circle, would it be pi r squared divided by 6?
If, there you go. I was thinking, if you were to take a slice that was 1/6 of the circle, the area would be 1/6 of the area of the circle. Now, When you say take a slice, that's a sixth of a circle, Brady. How are you measuring that? What are we taking the sixth of? The degrees, you could. So 360 is all the way around. Yes. What's the sixth of 360? 60. Yeah, 60. So if your central angle were 60 degrees, then the area of the sector would be a sixth of the area of the whole circle, right? Because we're doing proportions, we're doing squared quantity to squared quantity, it works. When you do proportions, the units have to match up. Okay, so what can we do though instead of using degrees? Is there another way besides degrees that we've been working on? Because remember, if we're using lengths or distances, we can't use degrees. What? Rads. There you go. So instead of using 360, let's use what? How many rads? 2 pi rads. Yeah, 2 pi rads. Now, be careful. When we're talking about pizza pies, that's 1 pi. But all the way around, 1 pizza pie is 2 pi rads. Everyone straight? Clear? Okay, good. So let's set up a proportion. Proportion. A proportion is basically someone who's in favor of portions, right? Right? Like we're gonna.
Really good at it.
He's really good at it. Yeah, he's like, I don't overeat. I'm professional portion. I portion out my meals and I don't get fat. Right? Real pro. I'm an amateur. I am not a pro. Here's how you can set up proportions. You could say the part is to the whole as the part is to the whole, right? Or you can do the part A is to part B as the whole A is to the whole B. Either way, if you set up your proportions that way, let's label this. Part A is to whole A as part B is to whole B. There you go. We'll kind of match it up. So those are the 2 ways you could do proportions. It doesn't really matter. If you want to verify by cross multiplying, you'll see that your cross products in either case are exactly the same. Okay. So what can we do for our proportion? Let's do the part. So we'll do the sector to the entire circle. Okay. So let's do that. On the sector, I'm going to take a part of a full rotation, call it theta, right? And that's going to be associated with the area of the sector. Okay. The theta of the sector is to the area of the sector as the area of the circle, or the theta of the circle is to the area of a circle. Yes, yes. Now I can do that because I'm using the same units. The units on the top are the same as the units to the bottom. So what I'm doing is I'm doing small, small to big, big. I'm doing corresponding sides. Yeah, thanks, Scooby. So I'm doing this version down here. That's the version I'm doing. Yeah. Yeah, Scooby-Doo in the hallway. He shows up every once in a while. He's having a good time always. Now, I'm going to use theta. I'm going to get rid of the subscript sector. I'm going to use theta and A. In other words, I'm not going to use the subscripts anymore. What is the theta for the entire circle? If you go all the way around to complete the full circle, no, Brady, we already transferred from that. Thank you. 2 pi radians. Okay. That's the theta for the whole circle. And what is the area for the whole circle? Pi r squared. Muy bien bien. Okay. So what we have now is a proportion. We want to come up with a formula for the area of a sector. Let's go ahead and cross multiply. Okay. You can always do that.
Divided by r squared. Yeah.
Well, first of all, what happens with your pies? You could do this before they divide out. Okay, so now let's cross multiply. I'm going to do this first. You're going to get theta times r squared equals 2 times a. Now I want to solve for area, okay, because I want a formula for the area of a sector. So all I got to do is divide both sides by 2, and I get the area equals theta r squared divided by 2. But instead of writing it as a fraction, dividing by 2 is the same as multiplying by what? 1/2. I'm going to pull the 1/2 out front and call it 1/2. And then I'm going to commute the two factors. I'm going to put r squared first, theta. And there you go. That is the formula for the area of a sector. Now, what do we have to use for theta? Will degrees work? Heck no, because look at the units. If you had radius measured in feet, you would have r squared, so feet squared, square feet, that's the units we want, times the angle in degrees would give you square feet degrees. And that's not a unit of area. Degree feet, square feet, degree square feet, right? People with square feet, I feel sorry for them, man. Where do they buy their shoes? They got to buy square shoes.
Buy the shoes and then they use the box.
So they buy the shoes, toss the shoes away, and use the box for their nice. That's like Clementine. Y'all know the song Clementine? Oh my darling, oh my darling. Oh. Yeah, her feet were so big, she had to wear herring boxes without topses. She wore boxes for shoes, and she didn't know how to swim. Poor girl. She fell into the foaming brine and died. The whole song is designed to scare people into learning how to swim. That's how the song came into existence. Can you believe that? Yeah. Yeah. Drove her ducklings to the water every morning just at 9. Hit her foot against the splinter, fell into the foaming brine. Oh my darling, oh my darling, oh my darling. You are gone and lost forever. I'm dreadful sorry, Clementine. She didn't know how to swim, so she drowned. And then the next verse, how I miss her, how I miss her, how I miss my Clementine. But then I met her sister and forgot my Clementine. Oh my gosh, what a horrible story. It's a kid's song.
Did the sister at least not spend?
I don't know. I think he just kept her away from the foaming brine. Yeah. Anyway, we have to use radians there. We have to use theta in radians or the units don't work. Okay, so let's go to the box. If theta is the central angle of a circle whose radius is r, theta is measured in what? Radians. Then the area of a sector is this. Area equals 1/2 r squared theta. There it is. There's the formula. Did we need it? Nah, we derived it. But if we're going to use it repeatedly, it would probably be worth memorizing it. Yeah. So memorize this as well. So we got two formulas. You got S equals R theta, and then you got area is 1/2 r squared theta. You got to memorize both. Both of these have theta measured in radians. Notice there's no pi in the area of a sector. That's interesting, right? It's just a function of the radius of the circle and the angle in radians. Okay. All right. So here's the problem I made up. Example 4. Mr. Kilford, y'all know him? Yeah, he's like my BFF. In fact, he might even be my Valentine today. We'll see. Yeah, no, Jack was. Sorry. Mr. Kilford just scarfed down a slice of Freudian pizza, right? He's a psychology teacher, so he likes to order Freudian pizza. Now, what is Freudian pizza? It's kind of gross, but here it is. It has thin slices of Sigmund Freud on it, as you can see. Right? And don't worry, that's not blood on his beard and forehead and nose. That's marinara sauce, right? Yeah, pizza, tomato sauce. It's a pizza. There's a Freudian a pizza, okay? Slices of Sigmund Freud. It has a 40-degree central angle. Now, I know you're saying to yourself, how does Mr. Kilford know that the central angle is 40 degrees? Well, here it is. He always measures them before he eats them to make me happy. He knows I'm a data collector. If the slice came from a 14-inch diameter Freudian pizza, I think you can get these at the New York Pizza Pub next week. Five, maybe.
No, I actually did the calculation.
Oh yeah, it would be 9 slices.
9 slices of pizza.
Yeah, yeah. If the slice came from a 14-inch diameter Freudian pizza,
Slices divided by an even number. It's weird.
it's odd, but it's not peculiar. Find the perimeter of the slice, Kilford 8. Find the perimeter of the slice, Kilford 8. Find the perimeter of the slice, Kilford 8. Okay, so, all right, so let's go ahead and try to ignore Brady over there. No, Brady, keep going. Like I said earlier, if you have a way to do it that makes sense to you, you just forge ahead, right? Like Jensen did earlier. But for the rest of us, the masses, we're going to try and systematically come up with an algorithm, right? Algorithms are what math are about. We like to systematize things. Creative thinking is great, but systematizing things is good too, right? So if I want the perimeter of this slice right here, I need to know the radius and the arc length, right? And then I would add them all up. We could say the perimeter, P for perimeter, not pizza, is R plus S, right? Or 2R plus S, yes? Yes, yes. Now, which of these things do I know? Well, I know the radius of the pizza is what? If it's a 14-inch diameter, 7 inches, and I'm going to use units. And then how can I figure out the arc length S? Well, it is what? What's the formula? R times theta, right? So I know that that's going to be 7 inches times, now theta was given. Let's come over here. Theta was given to be 40 degrees, but I can't just plug 40 degrees in there because then I end up with inches degrees. We need to convert it. Now I'm going to convert this one off to the side. When I did the other calculation, I did it in the problem, but I'm doing this off to the side because we're going to use it more than once. So 40 times, I want degrees to divide out. I want radians to appear. So I multiply by pi over 180. Now, because this is an angle in radians, instead of multiplying the pi into the answer, I want to leave pi visible. So I'm just going to do the 40 divided by 180, okay? And then I hit math, enter. 40 divided by 180, enter, and then math, enter. 0.222222222. Math, convert it, and we get 2/9. So the angle is 2 pi 9ths, and I'm going to put rads behind it again because it's radical. All right, now I can come over here and insert 2 pi 9ths, rads, and look at your units before you proceed. What's inches times radians? Inches. Yeah. And that's what we want. So I usually don't work left to right, but I'm out of room there. So 7 times 2 divided by 9. Notice I didn't put the pi in there. I hit math, enter, and I get 14 pi 9ths inches. Now, as we said in the warm-up, that's an exact answer. But because it's not an angle in radians, it would be nice to multiply it out so that we have a truer appreciation, yes? Okay, so if you want to multiply that by pi, you can, boom. So that arc length is going to be 4.886 inches. All right, now that I have that piece of the puzzle, I can come back to the perimeter. So the perimeter, remember, was 2R plus S. And now we can plug in. That's 2 times 7 inches plus the arc length. Now, which version of the arc length do I want to use here? Do I want to use 14.886, which is a rounded approximated answer, or 14 pi 9ths, which is exact? The exact one. Very good. So that's why it's good to have 2 different versions of the answer. We don't want to have rounding error ever. If we can help it, we use the actual answer. Now, you could also store it on your calculator, but then you'll lose it when you walk away from the problem. 14 pi 9ths is still there, ready to go. All right, so now that we have it written on our paper, inches plus inches is inches. The units match. So we'll just type it in. 2 times 7. I don't know what that is, so I'm just going to type it in. Okay, plus 14 pi divided by 9. Okay, so that's 18.886 or 887 inches. Now, I didn't give an exact answer to this, but you could have. Well, no, you couldn't have, because the first one didn't have pi in it. So this one, you couldn't factor out the pi, in other words, from both terms. So this is about as good as we can get. If we needed that number for anything else, we could store it as like alpha A. Boom. Now it's there. All right. So the perimeter of the slice was 18.8 inches, right? So that could be an indicator of how big the pizza was, right? Hey, Kilford, how much pizza did you eat? You know, I had one slice of Freudian pizza. It filled me up. Well, how big was the piece? Well, I don't know, but if you walked all the way around it, you'd walk 18.886 inches. And I'm like, wow, that's a lot, right? You set the pizza slice on the floor and you tiptoe carefully around it all the way, and you come full sector and you're like, man, I'm exhausted. 18.886 inches. You know, I think I need to refuel now with a little Freudian pizza, and then you eat it. Now, the bell is going to catch us. But now, tomorrow, when we come back, we are going to figure out not just the perimeter of the slice that we already know, we're going to find the area of the face of the slice. And by face, I don't mean Freudian's face, but the whole face of the pizza. And then we're going to figure out the true measure of how big the slice was. We're going to figure out its volume. And by that, I don't mean how loud the pizza's screaming, eat me. I'm talking about how much space it takes up in Kilford's stomach. Yeah. All right. What a great day. Brady, I have a roll just like that.